All right, hello pre-calculus. This is unexpected. I'm sitting here. It's Monday afternoon. The seniors just won the Powder Puff game against the freshmen, and I am making these videos for you guys. I'm a little sick, so I'm sorry about my voice, but I told you I wasn't going to miss any more days, but you can't control life sometimes. My grandmother passed away Sunday night. She was 95, and we were really close, and so I'm flying back to Nashville Tuesday night. I'll be gone Wednesday and Thursday, so I am missing block day, and I'll be back Friday. So I'm hoping that these videos will help you, because this is a really important lesson that I did not want to miss. But I'm going to be nice, and I'm going to chunk it up for you so you can take some breaks. I'm going to give you 4 videos. They're each going to be 5 minutes long, and there are 4 things that we need to learn today. So you can watch the videos right back to back to back and then work on the assignment, or you can kind of do one video at a time and go through the assignment. So what we're doing is we're building off of yesterday's lesson where all we did was graph sine and cosine. And we just graphed the basic y equals sine. And we didn't have any shifts, any stretches, any changes to the graph. But today we're going to do 4 different things. Okay? So we're going to use the standard form of a trig function as our base formula for the rest of the week. Okay? And that formula is y equals, sorry, I was going to do y equals mx plus b for a second. Y equals a times the sine, and then there's a little b here, of x plus or minus c plus or minus d. And that might look complex, but notice that there's still the sine of x hidden in there. It's just we're adding 4 different numbers, and those numbers are going to maybe move the graph up and down. Maybe one of them stretches it. So we're just taking this basic formula that we learned yesterday, and now we're going to add to it. Okay. So the first thing we're going to do is use the calculator to graph y equals sine x, y equals 2 sine x, and y equals 3 sine x. These affect, we're working with A right now, which is amplitude, the amplitude of the graph. So we're going to take a look on our calculator, and we're going to type these in. Okay, y equals sine of x, and we're going to do y equals 2 sine of x, and then we're going to do y equals 3 sine of x. Make sure we're in radian mode, which we are, and we're going to hit graph. Actually, I'm going to stop that, and I'm going to press zoom 6 because I want standard view. And take a look. There's the first one. That's sine of x. There's 2 sine of x. And there's 3 sine of x. And so you can see how it changed. Let's kind of zoom in on the graph. Take a look. It says on our notes, use the window 0 to 2 pi for the x-axis. So I'm going to press window. And instead of x minimum being negative 10, I'm going to make that 0. And then instead of x maximum being 10, I'm going to make that 2 pi. And the minute you push down, it's going to change it to a decimal, but that's okay. And my x scale, that's how much you want the x-axis to count up by. I'm going to do that as pi divided by 2, and then push enter. And notice it's telling me that right here. And then it tells you they want the y-axis to be from negative 3 to positive 3. So my y minimum is negative 3, my y maximum is positive 3, and my y scale is 1. Again, rewind that if you missed how to go here, but you press window to open this option. Then we push graph. Now we can get a little zoom in. There's the regular sine graph that we graphed yesterday. There's the 2 in front. There's the 3 in front. So I'm hoping with that colored visual, you can see what happens when we graph this, which is the basic, or when we put a 2 in front of it and a 3 in front of it. In standard form, which I'm going to make you write this about 4 times today, y equals a sine b of x plus or minus c plus or minus d. The a is the amplitude. And what is the amplitude? It represents a vertical stretch. So it just stretches the graph vertically. Use your calculator graph y equals 2 sine x and y equals negative 2 sine of x. So we'll use our calculator one more time. And we'll clear this out. Y equals 2 sine of x and then y equals -2. And watch when these graphs appear. Watch what happens when the negative graph appears. There's the positive one, up, down, up. Then this time it goes down, up, down. Okay? So when we have a positive number, we know with the sine graph from yesterday, sine starts at 0, it ends at 0, and it middles at 0. But since there's a 2 in front, instead of going up to 1 and down to -1, it's going to go up to 2 and down to -2. It stretches it vertically. With me? And then over here, -2, we know that sine starts at 0, middles at 0, ends at 0. But this time it's going to go down to -2 first and up to +2. Okay? So in standard form, if you ever have it, y equals a sine of b, x plus or minus c plus or minus d. When the a is a negative number, the graph reflects over the x-axis. Okay? Which you can see on this one, it goes up, and then it goes down, and it goes up again. But with this one, it goes down, and then up, and then down. So you can follow. You always read the graph left to right. Okay? What's our timer at? Let's see here. 6 minutes. Oh my, I already went too long. Okay, I lied. It's not going to be a 5-minute video. But this one did have an introduction, so the other ones will be shorter. Okay, without your calculator. I bet I can get it under 8 minutes, though. Without your calculator, sketch the graph of y equals 3 sine x and -3. You ready? Sine, where does it start? Starts at 0, ends at 0, middles at 0, and then we have the 2 humps. But this one has a 3 in front, so my amplitude is 3. So I'm going to go up to 3, down to -3. This is going to be a much taller sine graph. That was terrible. You with me? A much taller sine graph. All right? You right? You with me, Sebastian? Jack? Josh? Y'all better not fall asleep already. All right. What about the next one? Y equals -3 sine of x. It starts at 0 still, middles at 0 still, ends at 0 still. This time it goes down 3 first because it's negative. Okay? Put that point there, put that point there. What about the next one? Y equals 1/2 sine of x and -1/2. Well, we know where it starts, we know where it middles, we know where it ends, but this time it's only an amplitude of 1/2. So it's actually a little flatter. 1/2 doesn't go all the way to 1. It just goes to 1/2. You with me? And -1/2 sine, this one, starts at 0, middles at 0, ends at 0, and this time it's negative, so it just goes right there to -1/2 and +1/2. Okay? Let's do a cosine and then we'll be done. Without your calculator, sketch y equals cosine and y equals 2 cosine. Well, we learned yesterday that regular cosine, so I'll do this one in red, regular cosine starts at 1, ends at 1, drops to -1, and then has these 2 on the axis. And it kind of makes like this, almost like a V, but it's curvy. Okay? That's a cosine graph that we learned yesterday. Now watch with blue, watch how it changes when there's a 2 in front of it. When the amplitude is 2, instead of starting at 1, like normal, doesn't start there, it starts at 2. And it ends at 2. And then instead of dropping to -1, it drops to -2. These are still on the axis. But look, there's our V, our 5 points. And then we make this curvy, because a cosine graph is curvy. So look at the difference between the red and the blue. The red has an amplitude of 1. It's a normal graph. The blue has an amplitude of 2, and it's vertically stretched up 2. So you can try number 6 on your own, because one's a cosine graph, one's a sine graph, so kind of put it all together. But if you need to watch this again, please go watch it. But in summary, I've got one sentence summary. Use this equation, and if you ever see a number in the A spot, that is a vertical stretch. If it's positive, it stretches it vertically and it stays the same. If it's negative, it stretches it vertically and it reflects over the x-axis. But this video is on amplitude and it is the letter A. Next video is about the letter B and how it affects the graph.